Alright, so in this video, I'm going to solve a challenging system of equations. So for my first equation, I have x plus y is equal to 4. And for my second equation, I have x times y is equal to 24. So at first glance, this might seem simple, but it's actually a lot more complicated. So I'm going to first start by using my first equation and solving for y. So my first equation is x plus y equals 24. And to solve for y, I'm going to subtract x on both sides. So I get y is equal to 24 minus x. Or sorry, it should be x plus y is equal to 4. So if I subtract x, I get y is equal to 4 minus x. So now I'm going to label this equation 3. Now that we have the value of y, I'm going to go back over here to our second equation, x times y equals 24. And if x times y equals 24 and y is equal to 4 minus x, then I get x times 4 minus x is equal to 24. And now if I distribute the x, I get 4x minus x squared is equal to 24. And now I'm going to subtract 24 on both sides. So I get negative x squared plus 4x minus 24 is equal to 0. Now I don't want my coefficient for my highest degree term to be negative. So what I'm going to do is I'm going to multiply both sides by negative 1. So now if I distribute this, negative x squared is positive x squared, negative 1 times 4x is negative 4x, negative 1 times negative 24 is positive 24, and 0 times negative 1 is obviously just 0. So I get x squared minus 4x plus 24 is equal to 0. Now we have a quadratic equation, so to solve this, I'm going to use the quadratic formula, which is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, a is 1, b is negative 4, and c is 24. So I get x is equal to negative 1 plus positive 4 plus or minus the square root of b squared, which is negative 4 squared, which is 16 minus 4 times a, which is 1, times c, which is 24, all over 2a, so 2 times 1. Now this is equal to 4 plus or minus the square root of 16 minus 24 times 4 is 96, all over 2, which is equal to 4 plus or minus the square root of negative 80 over 2. Now, the square root of negative 80, I can rewrite as the square root of 80 times the square root of negative 1. And before I do anything with the square root of negative 1, I'm going to first simplify the square root of 80. So the square root of 80 is equal to the square root of 16 times 5, which is equal to the square root of 16 times the square root of 5, which is equal to 4 root 5. So I get x is equal to 4 plus or minus 4 root 5 times the square root of negative 1 over 2. And if you guys already didn't know, the square root of negative 1 is equal to the imaginary number I. So I get x is equal to 4 plus or minus the 4 root 5i over 2. And now I can divide both these terms by 2. So I get x is equal to 2 plus or minus 2 root 5i. So this means that I have two solutions of x. I have x is equal to 2 plus 2 root 5i, and x is equal to 2 minus 2 root 5i. And for each of these solutions of x, I need a solutions of y, because remember, we're not just solving for x, we're solving for these solution of x and y. So recall how y is equal to 4 minus x, meaning y1 is equal to 4 minus 2 plus 2 root 5i, which is equal to 4 minus 2 root 5i which is equal to 2 minus 2 root 5i. And for y of 2, I get 4 minus 2 minus 2 root 5i, which is equal to 4 minus 2 plus 2 root 5i, which is equal to 2 plus 2 root 5i. So my solutions are, I have two solutions, 2 plus 2 root 5i, comma, 2 minus 2 root 5i, and 2 minus 2 root 5i, comma 2 plus 2 root 5i. Alright, so in this video, I'm going to solve the equation 16 to the power of x is equal to x to the power of 2. So to solve this, I'm going to first start by taking the power of 1 over 2x on both sides. So I get 16 to the power of x to the power of 1 over 2x is equal to x to the power of 2 to the power of 1 over 2x. Now, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So we can use this property for both of these terms. 16 to the power of x to the power of 1 over 2x is equal to 16 to the power of x times 1 over 2x. And x to the power of 2 to the power of 1 over 2x is equal to x to the power of 2 times 1 over 2x. Now, the x and x cancel out on my left-hand side because they multiply out. So I'm left with 16 to the power of 1/2 on my left-hand side. And for my right-hand side, the 2's cancel out. So I'm left with x to the power of 1 over x. Now, my goal is to turn the left side to be in the form some number to the power of 1 over that number, so we can make that number our solution. Well, right now, this means that 16 and 2 have to turn into the same number. So we need to rearrange this so that 16 and 2 are the same number. So to do that, (16) is the same thing as 4 squared. So I'm going to rewrite it as 4 squared. So I have 4 squared to the power of 1/2 is equal to x to the power of 1 over x. And now remember, these two multiply. 2 times 1/2 is just 1. So I'm left with 4 is equal to x to the power of 1 over x. Now 4 is the same thing as -2 squared. And 2, our exponent here, I can rewrite as 1 over -1/2. And I have this times -1. So I have 1 over -1/2 times -1. And remember, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So this -1, I'm going to move to be an exponent of -2. So I get -2 to the power of -1 to the power of 1 over -1/2 is equal to x to the power of 1 over x. And -2 to the power of -1 is 1 over -2. So my solution here is -1/2. Alright, so in this video, I'm going to solve a challenging exponential equation. So the equation is x to the power of x is equal to 2 to the power of 2048. So to solve this, I'm going to first start by writing this as 2 to the power of 2 times 1024, where I rewrote 2 to the power of 2048 as this. So x to the power of x is equal to 2 times 1024. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So I can rewrite this as x to the power of x is equal to 2 to the power of 2 to the power of 1024, which is equal to 4 to the power of 1024. Now I can rewrite 4 to the power of 1024 as 4 to the power of 512 times 2. And I'm going to use the same property. So this turns into 4 to the power of 2 to the power of 512. And 4 to the power of 2 is 16, so this is 16 to the power of 512. Now, I'm going to do it for one last time. 512 is the same thing as 256 times 2. And I'm going to write this as 16 to the power of 2 to the power of 256. And 16 to the power of 2 is 256. So I get 256 to the power of 256 is equal to x to the power of x. And because both the base and the exponent are the same, this is right. So this is my answer. Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. So we have 27 to the power of 9 over 9 to the power of 3. Now, the first thing we want to do is we want to make these two the same base, because if we do that, we could simply divide them with each other. Now, what is a common base of these two numbers, 27 and 9? Well, 3 would work. Now, 27, this is equal to 3 to the power of 3. And 9, this is equal to 3 squared. So let's replace 27 with 3 to the power of 3. So now we have 3 to the power of 3 to the power of 9 over, now I'm going to replace 9 with 3 squared. So now we have 3 squared to the power of 3. Now, if we have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 3 to the power of 9, this is going to equal 3 to the power of 3 times 9 is 27 over 3 to the power of 2 times 3 is 3 to the power of 6. Now, if we have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So right here, we could think of a as 3, m as 27, and n as 6. So this is going to equal 3 to the power of 27 minus 6, and 27 minus 6 is 21. So this would be 3 to the power of 21. So this is our answer.